Good evening. So class time is from 5:30 to 7:30, yeah. And class days are from Monday to Friday, yeah. So we will, yeah. So yesterday we left at hybrid blockchain. So we will do a small recap before we go to the next topic. So yesterday we talked about blockchain, and core is a system that comprises of a transaction, which is immutable, which is immutable, and is decentralized, and has encryption, and has consensus mechanism. And for blockchains like Ethereum and Solana, they do have what we call smart contracts. So we also looked at the various transactions or record that can be recorded on a blockchain, or that needs a blockchain. So such transactions were RAND registry. We have an example of a case in Sweden, RAND registration. So replacing requirement of for research of deeds. We have personal identification, which I gave all digital identity, which I gave the case of Dubai and also Estonia. So they have been able to decentralize. They have been able to decentralize. Hello, hope you can hear me. Hello.
Yeah, I can hear you.
Okay. So
Damaris, can you hear?
Hello, yes, I can.
Okay, thank you. So Dubai and Estonia have been able to decentralize their ways of replacing birth certificate and death certificate, driver's license, and also social cards. In transportation and supply chain, I gave an example of Masek and IBM in form of bills of landing, tracking, certificates of origin, and international form. So when you do supply and shipping, you need certificate of origin, like these goods are originating from Kenya, heading to this specific destination. So with blockchain, it's easier to track the certificate of origin, and also be able to pay. Sometimes goods that are shipped, sometimes the owner of those goods is not paid in advance. So you have to, like, there has to be a trust of there is a need of trust, a way to show that trust. So with blockchain, you can be able to do that. In banking, I mentioned something about JP Morgan, and also there is the UBS, Russia's S-Bar Bank. That is in form of document storage, increased back office efficiencies. That's the one advantage that blockchain has been able to speed up. And also in lending, in DeFi, that is decentralized finance, you don't need all the KYC. That KYC is know your customers. In DeFi, you don't need to know more about the user when you are lending. So yeah. In manufacturing,
Quick question.
Yeah.
Why don't I need to know any customer when doing decentralized finance?
So when doing decentralized finance, the currency that you hold, let's say for example, you hold a USDT, and that that coin that you're holding or you are staking guarantees that if you give it to me and then I give you like real cash, fiat currency, I lend you the fiat currency, then I have guarantee that it's that USDT to me is like collateral to you. So there is no need like you fill in a lot of paperwork for you to receive loans in blockchain or in decentralized finance. Yeah. Yes, Damaris. I hope,
Hello.
yes.
Can you say in DeFi there's no need for KYC because you have to input a collateral?
Yeah. So I've given an example of USDT. So if Duncan owns a USDT and he wants me to lend him fiat currency, the normal currency like Kenya shillings, then there won't be a need for him providing all those documentation, because I'm assured that even if he doesn't return, I still hold USDT, which increases in value in real time. So even if he doesn't return the cash that I've lent him, he won't. I won't lose, because I will actually have value, because I'm now holding his USDTs. And then for the unbanked people who are not banked, like in sub-Saharan region, most people are not most people are unbanked. They don't have access to banking system. So with blockchain, before equity came, there was what do we call this bank? It's a big bank here in Kenya. Bankrest Bank. Bankrest Bank used to ask people who wanted to bank with them if they have a salary of more than 20,000. So for you to create a bank in those days, you needed 20,000 shillings and above, because when you are withdrawing, they wanted that the float of your bank to be at 20,000. And then you had to fill a lot of paperwork. You have to say that you are doing this, you have this job, you have this kind of house, you have this kind of land. And hello. Can you hear me? Hello. Hello.
I think we lost you a bit there.
Okay. So I was giving an example of sub-Saharan Africa in that most people, almost people are not banked, and before Equity and other banks and other banking services came up, Bankrest used to ask for a lot of documentation. Even nowadays, they still do ask you a lot of KYC. They just want to know if you have proof of identity, proof of residence, everything. All those KYC details they normally ask. Then it becomes hard for people who don't have those IDs to be banked, and they don't have any other way, or they don't have any other form of a banking kind of banking. Then in the recent years, Equity came, whereby somebody you didn't even need you didn't even need money to create an account. So most people were able to create accounts in banks, because that requirement for creating an account, one of them was reduced. Even students these days, they do create accounts without even having an ID card. Then came mobile money, which is M-Pesa. M-Pesa normally you do provide one that is identity, your ID card, which is not a lot of document that you provide. So with blockchain with blockchain and decentralized finance and smart contracts, one is able to create a wallet without having to prove your identity, without having to fill all those details that this is Duncan, I'm from this country, I'm from this, because blockchain is it doesn't have borders. It's just the way it doesn't have borders. So yeah, that's what I meant with less KYC information. So in manufacturing, there is a Crando to grave documentation of any assembly or sub-assembly. I had an example of such in manufacturing. In Denmark, let me share that example. So in Denmark created a vehicle wallet. So the problem they were trying to solve is that during a car life cycle, it undergoes various phases and activities. That is test, repair, loan, insurance, and changes in ownership. So in this these four yeah, 1, 2, 3, 5. So these 5 instances are the key points where when you are trying to create a solution on blockchain, you have to see, you have to record the test that the car has been undergoing all those years, or if from the previous owner. So when a car is sold from one person to another, there can be a lack of information. There can be lack of information from either the buyer or seller. On the seller's side, the car could have undergone an undesirable rebuild or even be stolen. On the buyer's side, the buyer could never register the car, which could result in continuous taxes for the original seller if the new buyer does not register the car. So the solution they came up with is creating a vehicle wallet. Is a partnership between payment services provider and the Danish tax administration. It is a supply chain management tool where data concerning the car is saved in one distributed ledger and creates one agreed and shareable record of this vehicle history as it is transferred across the supply chain. This reduces the risk for the buyer and the seller and helps ensure Denmark receives all the proper taxes. So that was an example of in manufacturing, and more companies are joining in to create such infrastructures. And yeah, another thing I spoke about yesterday was in food distribution and providing location, lot, and harvest date. Supermarkets can pinpoint problematic foods. So example that I gave was Walmart and IBM food chain. Yeah, audits due to the decentralized and immutable nature of blockchain. Audits will fundamentally change the way people do audits. So people can go back and audit this specific cash was transferred to somebody illegally. I'm developing such an application which does audit in public.
Oh, you heard from the recording.
Hello.
Yes.
I think it's, I think it was maybe it was a mishap, but it's supposed to start at 5:30.
Hello.
Yes.
Okay. Today I'm having internet problem. Yeah. So I hope I uh, I didn't get lost. I hope I didn't. So the last bit was that I was saying that I'm creating something related to audit and transparency in procurement in such a way that each specific NGOs, if they are able to send, if a certain NGO organization sends an amount of money, that money is audited, and that money is audited and made sure that the specific project that money, that donation money that was sent to that particular organization was used exactly as the foundation had wanted, or the foundation had requested. And also in government procurement services, like we have seen several cases here in Africa, a government fund that they have been able to like borrow or get loans from other countries does not like fulfill what it was intended to. So let me share my screen. Yeah. So those are some of the things that we talked about yesterday. So before we dive deep into how the blockchain, or we dive into today's topic, I'd like to, I hope you can still hear me. Hello?
Yes, I can.
Okay. So before we dive deep into how blockchain works, we need to understand a little bit where blockchain came from, and the history of blockchain technology. So blockchain, hello. Hello.
Hello?
Can you hear me?
Yes.
Okay. Let me share my screen, and then we continue. So to understand the blockchain technology and how blockchain works, we need to understand the history of blockchain technology and where it begins.
You're muted.
Hello.
We can't hear you.
Okay. So to understand how blockchain works, we do need to understand a little bit about the history of blockchain and where blockchain began, because it's something that have been the development of blockchain is something that has been ongoing So to start, blockchain started, or the work of blockchain was started by Stuart Haber and W. Scott, who envisioned what many people have come to know as blockchain in 1991. The first work involved working on a cryptography, secured, working on a cryptographically secured chain of blocks, whereby no one could tamper with a timestamp of documents. So every record is the current database that we normally have do have timestamp, and they do have audit trail fields that is created at and updated at. Created at normally is used, and logged who logged in at which particular session. Those are audit trails in databases like SQL and MongoDB and the other MariaDB. So those audit trails are mostly for time stamping. And on timestamp, people are able to change. Malicious actors in a system or in a database are able to are, are able to change and hack systems and manipulate the way and manipulate the records and manipulate the records by changing timestamp. So with blockchain, the creation of a way to encrypt and secure the blocks with a timestamp that cannot be tampered with was something which has made blockchain to be successful. So in 1999, they upgraded their systems to incorporate the Marco tree. So yesterday I spoke about Marco tree. So today we'll speak more about Marco tree and what Marco tree is. That enhanced efficiency, thereby enabling the correction of more documents on a single block. However, it is in 2008 that blockchain history starts to gain relevance, thanks to the one person who or group that goes by the name Satoshi. So the first major uh, blockchain innovation was Bitcoin, a digital currency experiment. The second innovation was called blockchain, which was essentially the realization that the underlying technology that operated Bitcoin could be separated from the currency and used for all kinds of other inter-organizational cooperation. So from our diagram, we can see this is when blockchain originated and Satoshi deploying his, releasing his white paper. And it's during that time that blockchain was separated, or cryptocurrency was separated, and blockchain was identified, and there was an establishment that blockchain can be used in all other inter-organizational operations. The third innovation was called the smart contract. So initially, in 20 in 20 in 20 during 2010 to 2011 and 2012, Vitalik was working as a Bitcoin magazine editor or publisher in Bitcoin, and he suggested that Bitcoin should be upgraded and smart contract created, which most most programmers or people who were part of the Bitcoin's development process disagreed, and that's when Vitalik decided to go separately and create his own Ethereum network. So smart contract embodied in a second generation blockchain system called Ethereum, which built retro computer programs directly into blockchain that allowed financial instruments like loans or bonds to be represented rather than only the cash-like tokens of the bitcoins. That's how Ethereum was founded. The fourth major innovation is the current cutting edge of blockchain thinking is called proof of stake. Current generation of blockchains are secured by proof of work, which proof of work generally consumes a lot of energy because of the mathematical and difficulties that is needed for miners to validate a transaction. So more blockchain, sorry. So current blockchain like Avalanche, Zero, Ethereum are secured on by proof of stake, where uh, where users are given the native coins of those blockchains and hold and stake, and those coins are used to, if the company, like let's say for example Ethereum wants to upgrade their system, people do stake those coins for the systems to be upgraded. So we will dive deeper into proof of stake and proof of work in our next lesson, that is on consensus mechanism that different blockchain use and different organizations do use. So in which the group with the largest total computing power makes the decision. These groups are called miner and operate vast data centers to provide this security. In exchange for cryptocurrency payment. So miners are always rewarded in each and every blockchain. So for Ethereum is currently it's 3.0. Yeah. The new systems do away with these data centers, replacing them with complex financial instruments for a similar or even a higher degree of security. Proof of stake system are expected to give and actually in action. They are already in action. So the fifth major innovation on this horizon is called blockchain scaling. So currently blockchain has had an issue on scaling into real world. Every computer in the network processes every transaction. So this is raw, as which didn't compare with Visa and Swift. That was in 2018. Currently, there are some blockchain which have actually advanced in the processing speed of transaction and also the cost of transaction. Polkadot has a transaction fee of I guess 0.0001, while Ethereum currently has the highest gas fee. Yeah, but with the Ethereum 2.0 coming to live, I think it's supposed to come this year. We will see major changes in Ethereum. Yeah, so without sacrificing, a scaled blockchain accelerates the process without sacrificing security by figuring out how many computers are necessary to validate each transaction and dividing up the work efficiently. To manage this without compromising the legendary security and robustness of blockchain is a difficult problem, but an interactable one. A scale blockchain is expected to be fast enough to power the internet things and go head to head with the major payment middleman, that is Visa, Swift, and even PayPal of the banking world. This, hello? Uh, so the five major. So these five major innovations represents just the 10 years of work by an elite group of computer scientists, cryptographers, and mathematicians. As the full potential of these breakthroughs hits society, things are sure to get a little weird, and self-driving cars and drones will use blockchain to pay for services like charging station and loading pads. International currency transfer will go from taking days to an hour, and then to a few minutes with a higher degree of reliability than the current system that we have. So that was 3 years ago. That was in 2018, and some of the blockchain technologies right now in the world have been able to create transactions that are taking less, like 1.5 seconds or something like that. I'll check and I'll confirm with you. Yeah. So there is a big difference between Ethereum and Bitcoin, and that is one, Bitcoin has no smart contract, and it uses it uses C plus, I think C plus or C plus or C programming. Ethereum has a smart contract and uses Solidity and Viper, and which is a Pythonic programming language. Solidity is a combination of JavaScript and C+. We have Hyperledger, which has a smart contract and uses various programming languages, that is Golang, C++, and it depends with what you are doing. Then we have Zero, which also uses Solidity. Polkadot uses Solidity. Binance Smart Chain uses Solidity. Yeah. So yeah, for the purpose of our class, we will be using Ethereum, which uses Solidity and Pythonic. Yeah, but we will majorly work with Solidity. So to understand what blockchain tries to solve, or the two types of problems blockchain can solve, I'll give two analogies, and that one is the first analogy is email. It is common to share document in emails among colleagues and peers, resulting in repeated duplication of the document. Of the document, the duplication can be theoretically never ending. It is possible that one could be amended and tampered with independently of all others. As amended copies duplicate, the history of changes becomes ambiguous, which document becomes the correct, which documents becomes the correct one, which one can be relied upon to as the state of the truth. So sometimes when you are multiple editors in a document, or in a collaborative work, the document keeps on being duplicated, and in blockchain we call that double spending. Is the risk of especially in currencies, is the risk that a digital currency can be spent twice. It can be spent twice, or even, yeah, it can be spent twice. So yeah, the other problem in banking, digital payments become a part of daily life, has become a big part of our daily life. We expect a bank to act as a trusted third party to verify the user identities. that the sender has the necessary fund and the funds are transferred to the correct person. The central ledger held by the bank becomes a single point of failure, so which becomes a target of hacking. The potential existence of accessing and altering that database without a trace is possible. Yeah. So double spending is a big problem. Uh, it is a potential problem unique to digital currencies because digital information can be reproduced relatively easily by tech-savvy individuals who understand the blockchain network and the computing power necessary to manipulate it. So physical currencies do not have these issues because they cannot be easily replicated. So double spending is best described in a way that people are able to duplicate the same currency, the same currency, like faking currencies, and spreading that money twice. So the thief would send a copy of the currency transaction to make it look legit, or might erase the transaction altogether when double spending is involved in blockchain. Although it is not common, double spending does not occur when what is much likely, however, is cryptocurrency being stolen from a wallet that wasn't properly secured. So in our last, I think that will be our second last topic. We'll talk about wallets and how to secure your wallets and how you can safeguard your assets. So the most common method of double spending is when a blockchain thief will send multiple packets to the network, reversing the transaction so that it looks like they never happened. So when I was that was in 2008 when I was learning how to create blockchain. I accidentally created a smart contract that had an overflow error where it generated a numerous amount of tokens uh, in out of thin air, which could have resulted into a kind of a double spending. Because yeah. So in banking, if we go back to banking, I mentioned about a single point of failure. So with blockchain, we are able to eliminate that single point of in blockchain, we are able to eliminate that central point of failure, and we are also able to create trust among people who do not know each other directly and conduct transaction. So this also reduce or eliminate the need for a central authority in banks and government. Yep. So those are the types of problem blockchain can solve, and I think it would be good if we now dive deep uh, into how blockchain works. I've mentioned multiple of time about Markov tree and how Markov tree works. So we have seen Markov tree so Markov tree is the backbone of the blockchain. To understand the basics of blockchain, one should be aware of Markov tree and the related technologies in this. So before we dive into Markov tree, we'll have a glance on a hash function. The hash function is a function which converts the input data into a fixed length. Like the demonstration I had yesterday of Markov tree, of there's let me just get that link. So this the from the Andeas blockchain sample or demo, we I showed you how to hash data. So let's say this is Africa data school hash. So as you can see, the hash is being changed. So this is the hash we are talking about, which is used in Marco tree. Is a function.
We are not seeing that screen.
Okay. Sorry. Let me share this other screen. Yeah, this one. So can you be able to? Are you able to see my the other screen?
Yes, you can see the screen.
Okay, so this is Africa Data School. It's a hash. With all this, the hash is created. If we remove the spaces, the hash also changes. If we back a little bit, the hash goes back to the original hash. So everything in a blockchain or in blockchain, or when it comes to cryptography, everything including a space is has to be hashed. So if you have this data and you want to send it to your friend during the World War, people used to, or during the Roman War, that's when cryptography is first recorded. People converting like this sentence. This is Africa Data School, so we hash it manually by changing the order of words. School data Africa. So this was the previous or the olden ways of hashing, and people also do use that. So my friend who had or who knows how I do my hashing, but I start from all my encryption. I start from the last word to the first word becomes the last word, and the last word becomes the first word, and in between. Then if I have a decipher, I will be able to decipher this information that the sentence was supposed to be Africa Data School and not hash school data Africa. I will be able to make sense of this particular information. It's a good way of encrypting information, because the in during those time enemies would not be able to decode or decipher what was written in a letter. So that's the function of hash in those times. And in relation to blockchain, it's the same thing. So people who have this hash, they will be able who have this hash will be able to decode this particular hash. In password hashing, we have different hash functions when it comes to hashing password. Normally, most application use MD5. Yeah, I'll give more examples of hash algorithms or hash functions. Yeah, so converts the input data into a fixed length of data regardless of the length of inputted data. The output of the hash function is called hash value or hash code or hash in short. A hash function generates a completely unique hash with a fixed length for each inputted data. It is guaranteed that two hash functions will never collide for two or more different input data. For example, like the one we have done, if we do the example of hash me, it will be different from, it will generate a hexadecimal of 16 character. In the second example, that is hash me without a space, it will be different. Let's see this one. So if we do hash me, that is the hash. If we that this is the hash that has been generated. If we do that with a space, the hash changes. So in human mind, we know that is hash me, but for the computer, for computer or binary or machines, they know that is totally different. They are two different things. With a space, there is a space, and then there is an extra character that is generated on that hash. Not extra, but the same length of characters, but different characters. Yeah. Yeah, so that is hash function. Yeah. So different popular hash there are different popular hashes or hash functions that is MD5 secure hash algorithm 256. We have another SH that is secure hash algorithm 1 and secure hash algorithm 515. Each of them follows different cryptographic algorithms. Secure hash algorithm 256 is the popular one, which is followed by most of the blockchain, including Bitcoin, as we had mentioned. So Markov tree is the total build using a hash function. In short, a Markov tree is a formation a Markov tree formation is the process of making a single hash from a group of hashes. Making a single hash from a group of hashes, hash functions or hashes. So from we go back to this Andreas Brown blockchain. Okay. So from this, we have a number of blocks which are interlinked with the previous blocks. So from this list, with as from what we have said or defined, a Markov tree is a Markov tree formation is the process of making a single hash from a group of hashes. So the bottom blocks, that is L1, L2, and 3, and L4 are the data blocks. So these ones. So these blocks, the first block, this one, the previous block, has data inside here. The other one has data here, this one. The other one has data, and so on and so on. So they are interlinked together, and they are what we call leaves. So the main block, which is the root block, we can have it as I'm trying to look for an image of Markov tree. Let's see Markov. Sorry. a representation of how Marco tree looks like. Yeah. I hope you can be able to see. Hello? Hello? Hello?
Yeah, we can hear you.
Okay. So from this diagram, you can see that the top hash, or hash 001 plus hash 1, the same as in this block, in this demo of blockchain. We have the first plus the second, the first or the genesis hash together with the second hash, that is L1, L0 and L1, hash 1, hash 0 plus hash 1. And then we have other hash that fall into that tree. These are called leaves, all branches, leaves, leaves. And then we have other hashes that create. You can think of Marco tree. Marco tree was introduced by Raphael Marco, which explained it as a DNA, the way like a family tree, the way the way the DNA tree goes all the way to the grandchildren. So we have the root as the grandparents of the original parents, and then the DNA spread all the way to the offsprings. So you can think of Marco tree in relationship to that. So if we invalidate one single DNA of the offsprings, then that offspring or that block is removed from that Marco tree, and it's never part of that Marco tree. It will never be a part of that Marco tree. So there are people who do try to change, of which you cannot be able to change. It will be like destructuring or creating another human or another blockchain. Yeah. So that's the function of Marco tree, and that's how a blockchain is secured by Marco tree. Let's go back to our presentation. So they are the data blocks. The first step is to hash each. I think there's a lot of details. So the minimum number of leaves should be 2, and there is no upper limit. The next step is hashing two adjacent hashes into a single hash. That is hash 000 is concatenated with hash 01, and again hashed it by secure hash 256 to get hash 0. The same process is done to the other hashes, and the same way. So that is it is impossible to derive. The final hash is called root of the Marco tree. It is called Marco root. The validation of the existence of data in a Marco tree is an important process. The data to be validated is called target hash. As already mentioned, hashes are irreversible. That is, it is impossible to derive the target hash from the Marco root. So that the same way it's hard to get the exact DNA of the parent, the root parent, because so that no data can be validated by decoding the Marco root. The only way to validate a data in a Markov tree is to rebuild the tree. Target hash alone is not enough to rebuild the tree. One method to rebuild the Markov tree is by correcting all the leaves and arranging them in the same order and build the tree again. But this is a constraint for many applications and also time and storage consuming. If we study a Markov tree formation in little more depth, we can see that all of the leaves are not required for building the tree. Instead, a proof to reach at Markov root from target hash can be formed. This proof is called Markov proof. Markov proof is nothing but a correction of arrays of hash, which has been explained as I have explained. Yeah. So that's about Markov tree, and yeah. And now we can dive deep into now how blockchain works. So these are conceptual illustration of a blockchain, as you have also seen on this demo. So I'll keep referring to this demo because it's the basis of it's the foundation of what we will be doing in our next topic. So, and it's something that we will always be referring to. So every blockchain transaction goes through the same steps, regardless of whether it is used for financial transaction or product tracking. So the basic principle of the operation of any blockchain can be broken down into four distinct steps. A record is made of each transaction. So a blockchain or a record is made of a block is made of is a record of each transaction. The record, which contains certain details of the people making the transaction, is authenticated using the digital signature of each. Each transaction is verified to ensure its validity. So the verification of this transaction is done by miners. This verification process is completed by the computers connected to the network, each of which independently checks to ensure that the trade is legitimate. Because this is a decentralized process, it means that every node in the network needs to agree before the process can be completed. Once verified, each transaction is added to the block that gets hashed. As we have mentioned, we have seen the process how the hash is done into blocks. Blocks are basically the groups of transactions, records, and each one is unique. Each block also carries a code known as a hash value or a hash digest. So we have all a hash, which both uniquely identifies it and calls out its position within the blockchain. The hash also ensures the integrity of that data to show that it hasn't been modified since it was recorded in the block. In the block. Once complete, the block is added to the end of the blockchain. This brings us to the end of the blockchain creation and verification process. Once one block is completed, another block will soon follow, typically with just a matter of a minute, as you have seen. So this is block one. Once it has been validated, it will be hashed and secured. Then another new block is created, and the same case, it continues and continues and continues that way without having an end. We having a beginning with an yeah. So that's how blockchain works. And next part is what is blockchain immutability. So I mentioned about blockchain is immutable in our properties of DLT or distributed technology. that blockchain is immutable. Any validated records are irreversible and cannot be changed. So what does that mean? So it means that immutability can be defined as the ability of a blockchain ledger to remain unchanged. For blockchain to remain unaltered and unalterable, more okay. Oh, sorry. New share. Okay. Sure. Can you see now the notes? Hello?
You can see the note.
Okay.
Yeah.
Okay. So more concisely, data in the blockchain cannot be altered. Each block of information, such as facts or transaction details, proceed using a cryptographic principle or a hash value. We have talked about the hash value. I think for now, if somebody has a question, we can ask, you can ask. We have talked about the Merkle tree and the hash value. So that hash value consists of alphabetic strings generated by each block separately. Every block not only contains a hash or digital signature for every block contains a hash or a digital signature for itself, but also for the previous one. It also contains, oh yeah. So this statement was, every block not only contains a hash or a digital signature for itself, but also for the previous one. So how immutability is achieved is one of the key elements for that makes blockchain immutable is cryptographic hash, which is why blockchain is immutable. The main advantage of hash is that it cannot be reverse engineered. That's the only reason why it is so popular. The most popular hash function is secure hash 256, and there is an input that goes into the hash function with a checksum as the endpoint. In the below image, we can see the blockchain is disruptive. We have already done that. You can do more practice with different words and see the different generated algorithms. Not algorithms, but different words to see the different hashes that are created. I want to share something. So this is the image I'm talking about. So if we can confirm if this is the same hash which is generated. On a site. So this one is a bit different. I think we can add the codes. Blockchain is disruptive, is encrypted using this hash function, that is secure hash algorithm 256, and the output is this checksum or this number of characters. Yeah. So that's how blockchain works. We have different challenges that affect blockchain's immutability. and one of them is 51% attack. There are a number of changes. There are a number of challenges for this mechanism. However, the chief weakness can be possible of a 51% attack. What is this? Well, this term signifies that an attacker can acquire huge computing power over all other members of the network, in short, and it can be referred as to, it is referred to as controlling interest of generating power. So the in recent years, I think that was 2018 or 2019, China was about to reach that 51%, and they were about to do so. So that's why most people are moving to proof of stake, because proof of stake does not proof of work does not does not need power. That is does not need that power, or proof of work does not use power. It does not use that much power. So we have another big challenge, and that is quantum computing. Is this in this space is quantum computing, which is threatening blockchain trait of immutability. Experts at MBM have asserted that quantum computing has the ability to reverse engineer the public key of the blockchain network, which can find the private keys to break the system. There is no doubt in saying that there is a real and credible threat in the space, which is capable of affecting almost 50% of blockchains. So this one, the solution, experts have suggested that, one, the 51% attack can be tackled by creating a stronger protocol and by using a consensus algorithm such as a delegated proof of stake or just proof of stake algorithm. For the threat of quantum computing, many application developers have recommended integration of quantum cryptography into the core of blockchain. In the upcoming years, the blockchain architects created with quantum particles will be able to record all history in more secure way. That is the solution for the two major challenges. Yeah, so as we wind up, we'll talk about what a block is, because I've mentioned a couple of times blocks, and we are wondering if these blocks are the building blocks of a house. And yeah, so all the concepts and its components. So we will speak about I'll speak about block and its component. So the blockchain is a chain of data blocks. Each blocks can be thought of as a page in a ledger. So the individual blocks are composed of several components. Roughly, this can be differentiated into the head of the block header, and its body, block body. So the block header has the head of the blockchain. The head of the blockchain is divided into 6 components. We have the version of the software, the hash of the previous block, the root hash of the Merkle tree, the time in seconds, the goal of the current difficulty, and the nouns. The block body is conceived as the loading space of a track. It contains all transactions that are confirmed with the block. When a miner constructs a block, it validates the transaction. That is, he checks that the sender actually has enough money to spend. he can easily read this information from the blockchain. The miner looks in the past blocks to see if the sender has even gotten the Bitcoins or ETH. If he wants to send the 10 Bitcoins, if he wants to send the 10 Bitcoin, the transaction in blockchain, in a block, are not just in a list, but in a so-called Merkle tree. So we have spoken about Merkle tree. I felt like I needed to talk about Merkle tree before we even dive deep into how it works. So I'll demonstrate a transaction. So yesterday I did a transaction using MetaMask, and and so this the transaction I made yesterday. That is it contains these components. Let's check if it contains the components that we have talked about. So we have talked about transaction hash. This is the transaction hash. We have the status, we have the block number and block confirmation. Since the last one that was mined, we have the timestamp, we have the body, which contains all the transaction from the sender to the receiver and the value. And then we have the transaction fee, we have gas price, we have gas limit, and then we have gas used by transaction, we have nouns, and then we have input data. So take note of these ones. I haven't talked about them. The transaction fee, gas fee, gas limit, and gas used by transaction, nouns, and also the input data. Take note of that because we will talk about them in later lessons. So is it Ambrose who was asking about GUI? So this is GUI, which is one GUI, Lafre, which translates to 0.0000 something. It has an 18 decimal. It has an 8 decimal places. Normally, the fiat currency or PayPal, not PayPal, but PayPal has 2 decimal places, calculates it figures to 2 decimal places. That is, if you have $1, it will read as 1.001. So for ERC20 token, they do have, it has 18 decimal places. So I will talk more on deep on this, on transaction fee, gas fee. So transaction fee is quite explanatory. That is the price of the transaction. That is, yeah. So different transaction have different transaction fee. They have different fee. Yeah. So those are the components of a block. Yeah. Lastly, on this part is I hope you can see my screen. Hello?
Yes, I can see your screen.
Okay, the notes. Okay, so we have talked about a lot about blockchain, and we spoke about in the other notes I talked about 2 challenges, that is 51% and quantum computing. So we have other challenges in blockchain, and blockchain is not a cure for all. That you have to keep in mind, that blockchain is not a cure for all. So we have one challenge, and that is another challenge, that is immutability. A blockchain is an add-only list. Once data is added, it cannot be removed. Perhaps not a good fit when updating and deleting data is a regular occurrence. if your organization do delete and update data occasionally. Data storage. Databases are often used to store large amount of data, images, docs, app. However, blockchain is designed for small pockets of data. If data storage is needed, blockchain may not be a good fit. So, the solution for this one is a hybrid solution. I spoke of IPFS. There is IPFS. There is the other IPFS is the major, or is the most popular for storage of documents and for storage of data and for storage of images and docs and apps. Then talking about blockchain, sometimes I hope this class is not as difficult. Is I don't have I'm not talking a lot. I hope hello. I hope the class does not have a lot of words in it. So talking about blockchain, it's had some time. So the act of explaining blockchain to public officials and even individuals and civil servants is difficult. Delinking blockchain from Bitcoin and discussing how it can improve efficiency and strengthen mission effectiveness, and how it can strengthen mission effectiveness is hard. So when you are explaining this to different stakeholders, people always think that you are talking about Bitcoin. They all have that idea that blockchain. They have an idea that blockchain is all about Bitcoin. They think that blockchain is Bitcoin. And the moment you say that you do blockchain, I've had a difficult time telling people that I'm a blockchain developer. They asked me if I develop coins and if that is Bitcoin. So they normally associate blockchain with Bitcoin, and blockchain is a whole lot of things inside blockchain. So the cost is higher short-term costs associated with still emerging technology prevent its widespread use. Blockchain as a service product, you have seen different organization, that is Azure, Google, Amazon offering blockchain as a service. Oracle has the most expensive enterprise blockchain for Oracle. It's very expensive, but in terms of maintenance, it's cheap. But if products are starting to be offered that can allow for experimentation. There are brokers. People often flag issues such as energy consumption and scalability as blockchain broker. However, many of these are irrelevant to government blockchain implementation. It only applies it's only applied to proof of work consensus on permissionless and stroke public blockchain. So for private blockchain, for private blockchain, energy consumption is not a broker. So for Oracle blockchain, because it's a private blockchain and it's maintained privately, it's efficient. It doesn't consume a lot of energy, and scalability is easy. Then we have coding and governance models. Blockchain are known for eliminating the need for central authority, but this is not entirely true. They must be coded and governed by those entrusted within with key roles. Government must build a technical knowledge base to ensure these decisions are made well, even if the actual coding is outsourced. So there are policies. There was a question that emerged or occurred in a hackathon that I participated last year, which was sponsored by the UNODC, that is United Nations on Drugs and Corruption. And one of the questions was that if you are creating government applications on blockchain, and the blockchain is public and the code is outsourced, what ways can you be able to do, or what policies are there to control the open source? So there are a person who there is a task force here in Kenya, which is creating, I think, I don't know if they have been able to come up with a framework on ways they can be able to govern and create policies and governance models that can be able to see different applications built on blockchain. So in countries like Dubai, Denmark, they already have a legal framework on how they can be able to govern that. Recently, Salvador, they legalized Bitcoin to be a legal tender, and I know they are creating a governance and policies to govern the technology. Yeah, so those are some of the challenges and limitations, and some of them have been tackled with, and yeah, and also yeah. So one of them about talking about blockchain to civil servant and public officials. We have classes like these ones, and we have forums, we have webinars where people talk about how blockchain can be used in government, and blockchain is not necessarily used for cryptocurrencies. Yeah, we have countries that are adopting to blockchain technologies. So there is a green it's the field is, or the space is green, meaning that there is a lot of opportunities. You can come up with your own solutions and create uh, such tools on top of blockchain. Yeah. So yeah. So that's it on blockchain and how blockchain works, and challenges that we are facing, the limitations of blockchain, and yeah. So tomorrow we will look at why blockchain. I'll make it a short class. I'll make it a short class because I know it's a Friday. Yeah. Hello. If that's okay. Hello.
Hello.
Yeah, if that's okay, since it will be on a Friday, we will tackle why blockchain. I think I've given a lot of reasons, but we will do a recap tomorrow and see why.
Okay.
Yes. Hello.
Hello. Can hear you. We can hear you.
Yeah. So we will do a recap why we need blockchain in our day-to-day in our system, and we will see the different countries and different companies that are implementing blockchain technology into their infrastructures, and we will also be able to see the use cases in different fields. Yeah. So if someone has a question, feel free to ask.
Hello.
Hello. You can light on the.
This is a request.
Yes.
Can you hear me?
Yes.
Hello.
Hello. Yes, I can hear you.
This is a request. Can you upload the slides as well?
Okay. Okay.
In the inclusive of the Zoom recording plus the slides.
Okay. Okay. I'll do that. Yeah. Any other question? I will change the slides because I had created one slide that contains all the topics and all the course content. So I'm trying to separate them. I'm trying to separate the two. So you will have the slides in due time. Yeah. Yeah. So any other question? Hello. Hello.
Mhm.
Hello.
I think that's okay.
Okay. Okay. Okay. Ambrose, do you have a question?
Hello, can you hear me?
Yes. Yes, I can hear you.
Yeah, I lost connection. Sorry. I mean the training materials. When can we get them so that I can also go through them before the next lessons?
Okay. Is it okay if I just upload all the content and then we will be going through them together?
Okay,
Yeah.
because like now, maybe like what we did yesterday.
Mhm.
One feel like going back
Okay.
to yesterday to refresh, and then the one of today the same thing to refresh, and that's what I mean.
Okay. I'll do that. I'll upload the two slides. So I'm trying to change the slides so that they are able to reflect on the different topics that we have covered.
Okay,
Uh,
okay, you can do that.
yeah, yeah.
Okay, when
Cool.
you are done with that, at least let's. I mean, since you have it in mind to upload it for us, good.
Yeah,
At least it will be good. You break it down the way we are following it.
yeah. The way we are following it, because
Yeah.
yeah, yeah.
It's okay, thanks. That is all for now. The At least so far, well, maybe because I'm a technical guy, the the course has been very straightforward, and just that you're trying to get to some new terms,
Mhm.
but at least so far so good. It has been straightforward, and every technology which is on different terminologies.
Yeah, yeah,
Yeah,
yeah. So
it's okay. I
yeah,
don't have much.
yeah. So there are so many terminologies that have introduced in one day, and I hope they are not that much a lot to like handle.
No, 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 no. They are not that much, and at least at the same time they are user friendly.
Yeah. Okay.
Let me put it that way.
Okay.
Yeah.
Okay. So and then so tomorrow we'll be ending, I think, lesson one. Lesson is it lesson one? Lesson one, that is introduction to blockchain and why blockchain. So that next week we will start on Ethereum. We will now dive into Ethereum. We understand the Ethereum ecosystem, the environment, uh, and how you can the difference between Web 2 and Web 3, its benefit, and we will actually create a simple code. So for those looking to like who know Python, there's something came across with, and this is the Marco tree. Hello, can you see my screen?
Yes, we can see your screen.
Okay, so there is this link for those familiar with Python programming language. They can set up, and I'll set up. I'll set up. I'll show you. I'll do a demo on Monday. How a Marco tree works and how it's how Python script use to use using Python to calculate the Marco root. So these are code that you can play with. I'll also place it on the resources. Under resources, you will be able to find this GitHub depot, and you can use it to try out and see how Marco tree works. Yeah, from different
Okay.
yeah. So
Okay.
on the resources, I also uploaded the GitHub repo for this Andreas Brownworth blockchain. You can also check it and see how you can also play with it. And this one you can also try differently. You can try encoding your word, your own name, and see how your name is hashed. You can also try using MD5 encryption, and see MD5 encryption is this one is easy to crack. This one is easy to crack. You can try online MD5 encryption. You encrypt your word and see. So mainly that's why most websites are easy to crack and hack, because they normally use MD5. Most Web2 developers have not really realized that there are other ways to do hashing of their passwords, and that's why they have vulnerability, because MD5 is weak, and it's easy to crack. There are tools that there are tools online. There are tools readily available online. So if you have access to an SQL database, you can easily decrypt the MD5 hash. Yeah, so that's it for today. I hope you have enjoyed the class, and
Okay.
you're liking it. Yeah.
Sure. Yeah, it's okay.
Yeah.
Thank you.
So have a nice evening, and yeah, ciao.
Okay, thank you very much, Jordan. Nice evening.